I'm Rachana from Kanpur University. This is my research title, Classification of Breast Cancer Using Extreme Learning Machine. It's a machine learning approach. My presentation goes as follows. I will just focus on introduction, methodology, and results and discussions. As we all know, breast cancer, what is cancer? It's an abnormal or uncontrolled cell division or a cell growth. We'll call it as a cancer. If the uncontrolled cell division or a cellular breakdown is at the level of breast tissue, we'll call it as a breast cancer. It's the second most leading cause for deaths among women around the world. If it is detected the earliest, then the survival rate can be increased up to 85%. And mammography is the widely used screening methodology for detecting the cancer. It requires a sophisticated image processing methods for its interpretation. So there is a great need for computer-aided diagnostic systems, which include enhancement, segmentation, and classification. Enhancement can be done in different domains such as spatial and frequency domain. For segmentation, nowadays, majorly we are using a convolutional neural network, which is introduced to avoid the problem of overfitting. For classification, different machine learning methods are used, such as supervised and unsupervised methods. In literature review, we have studied different enhancement techniques, which are based on spatial and frequency domain.
Madam, I'm sorry to interrupt. Your slide is still in the first page, madam.
Okay, wait. Now? Hello?
Please go ahead.
Yes, madam. Yes, madam.
Now, is it
now
literature review?
Yes, madam.
Yeah. Okay. From the literature review, we have been studied different enhancement techniques, different segmentation techniques, which are based on convolutional neural networks, such as UNet, dense attention unit. Those are variations of convolutional neural networks. For classification, there are different traditional methods, supervised and unsupervised methods are being studied. Now coming to objective, the major objective of this paper is to classify a mammogram image using an extreme learning machine. And we have conducted the comparison analysis also. We have implemented 3 other methodologies, logistic regression, linear discriminant analysis, and support vector machine also. And the comparison analysis is conducted between the proposed and other 3 methods. Now coming to methodology, this is the proposed methodology block diagram, wherein
see literature review slide only.
Oh, now sir?
Yes, I can see methodology.
The input is obtained from DDSM dataset, that is digital database for screening mammography dataset. And after obtaining the input, this is given to pre-processing stage, wherein contrast limited adaptive histogram equalization is applied in order to pre-process the data and to remove noise, and it also increases the contrast and preserve the edges. After that, the segmentation stages, wherein we are using UNet. UNet is a U-shaped convolutional neural network model. It has an encoder and decoder part, wherein it basically what it does is it extracts the features. Then finally, we are going to classification, wherein we are using the extreme learning machine, and performance metrics such as accuracy, sensitivity, and specificity is defined here. Now, coming to extreme learning machine architecture, it's a feed-forward neural network. It contains input layer, hidden layer, and output layer with N nodes, M nodes, and P nodes. The only thing which need to be learned is the weight over here between the hidden and the output layer. So the only thing, the only parameter which need to be learned is this weight between hidden and output layer. Hence, the ELM, that is extreme learning machine, converges faster when compared to other traditional methods. Coming to results and discussions, these are 3 factors which we have obtained from feature extraction, that is LBP, nothing but local binary pattern feature extraction, then gray level co-occurrence matrix, and Gabor filter. From these 3, we are extracting the features. And is the visual representation of the LBP feature. LBP feature and GLCM and Gabor feature extraction. After that, we have compared the obtained results of extreme learning machine to SVM, logistic regression, and LDA. We implemented all three other classification method also, and it is found that extreme learning machine gets good result when compared to all other three. So in conclusion, what we can say is extreme learning machine, which is proposed for classification, it's evaluated for a performance metric and obtained 87% of accuracy, 90% of sensitivity, and 79% of specificity. And it is better when compared to other three existing supervised and unsupervised methods such as SVM, logistic regression, and linear discriminant analysis. These are some of the references which I have referred. Thank you.
Thank you for your wonderful presentation, ma'am.